And our final presentation this morning, or this evening, or this afternoon, wherever you are, sorry. Before we take a short break, is from Sheena and Dean from the University College London, who will be sharing a presentation about their students' projects with us.
Hello, my name is Professor Dean Mohammed Ali, and I'm here to present the Motion Input Project with my colleagues Sheena Visram and Sinead Tatan from University College London's Department of Computer Science. This accessibility technology project looks to augment a user's capabilities with low-cost webcam-based detection of their motions as inputs into a computer system. The project has been developed over 2 years with successive classes of computer science students. In its current iteration, there are over 40 students in computer science at undergraduate and master's level looking at different aspects of this work, and we are exceptionally proud of their efforts. Touchless computing has been around for over 4 decades in various forms, from light pens to light guns, and more recently, camera technologies, for example with gaming systems such as PlayStation and Xbox. All of these have had a range of user motions as inputs, and it's been possible through the development of new technologies. Most recently, depth cameras and infrared cameras have been entirely useful for higher fidelity ranges of human motion capture, but these come at a cost of hardware development and additional support of dedicated software and installation. So some of the system design policies that we have in place on this project is to enable as many users as possible to use modern computers touchlessly. It should be as ubiquitous as mouse, keyboard, and joypad, and operational in clinical, health, education, and any other sensitive user groups. I'm now going to show some examples of Motion Input 2.0. Here you've got 3-dimensional navigation, annotation of imaging scans, the ability to play games with your wrist, first-person shooters and other playable arcade games, and facial navigation. The students that worked on this over the summer were able to do this in such a way that the modules would become interchangeable on different platforms, focusing their efforts to create one constructed GUI for all of the components was quite a task. However, they succeeded in building out a single application which is now fully available on Windows. This application enables the selection of various modules to be used in lieu of the mouse, keyboard, and joypad.
Hi, my name is Sheena Visram. I'm the clinical lead for Motion Input, and also I'm completing a doctorate in computer science over at UCL. You can see Motion Input launching on the screen just now, and that's me. It always starts with a calibration phase, and I'm going to walk you through that. It starts off with keeping my eyes open and my mouth still. It's a really good way of just being able to recognize and track my face. Then closing both eyes for 3 seconds. Again, this is to pre-program for gestures that I'll show you in a moment as they're executed. Then smiling with my teeth. Followed by opening my mouth. And then lastly, you'll see this moves into clenching my teeth. And these are the first selection of gestures that we've decided to program into the system. And that's the calibration over. Let me clear the screen just so I can walk you through some of the different steps that we've built. So just with a smile, you move between no mode to cursor mode to menu mode. Now, no mode exists just to avoid unintended gestures. I'm in the cursor mode now. When I open my mouth, that opens up a dynamic area of interest. And then by moving my nose, I can actually navigate around the screen the same as you might do with a mouse movement. With relative ease, it's actually quite comfortable to do. In the future, it's intended that this would almost run in the background, so you'd be executing these gestures as something that feels quite intuitive without having to see yourself on the screen at the same time. Now, if I get rid of that dynamic area of interest and turn my head to the left, I can execute a left click, and that's the equivalent of a left click on a mouse. The same with turning right. Now, if I overshoot like you saw, it stops tracking my face, and so getting used to executing these gestures is really important. Getting that dynamic area of interest back again. I can move across to a PDF, and this is one of the lovely use cases that we've managed to develop within the system. Close my eyes and that launches up a PDF, maybe even a book as a really nice way of reading. Another smile within this mode, and the scroll mode launches, and that allows for me with relative ease again just to be able to scroll through a PDF in both directions.
Hi there, I'm Sinead, and I'm the Chief Software Architect of the UCL Motion Input version 3 project. So, to give you an introduction, Motion Input is a UCL project for touchless computing on existing platforms such as Windows, Mac, Android, and Raspberry Pi. It's built by students at UCL Computer Science. The solution is based on webcam-based gesture recognition, which allows users to control their devices using head movements, eye movements, full body movements, or hand gestures. Some of the main goals for this project are to focus on accessibility for all and leave no user behind, to provide a tech approach for those with varying motor disabilities, to enable room distant and touchless requirements to be met, for example, in sensitive environments, and to create an interactive way for people to use their existing devices and software in new ways. Some of the progress to date in versions 1 and 2 are that hand gestures have been enabled for classical mouse motion with Inair clicking. There are other hand gestures to control things like self-starting the system, scrolling pages, activating a virtual touchscreen, 3D model navigation, and enabling wrist motion control in various games. Then there's the facial navigation, which consists of the head movement module, which enables nose pointing, smiling, winking, left ear, right ear, and grinning as gestures, and the eye tracking module, which enables full use of the computer user interface with eye gaze to action commands as a mouse replacement. Then there's the full body gesture module with configuration. So this allows you to use it with or without equipment, to configure desired movements and the key mappings for those movements. And there's also calibration for this module. Then there's a Mac implementation for hand gestures only and a graphical user interface. So the main goals for version 3 are to greatly improve the robustness, accuracy, and ease of use for features currently implemented. We also want to improve the graphical user interface and user experience with feedback from public access. And we want to extend core motion input into applications for different niche use cases with added functionality. So here are some individual team overviews that are important for the ALS-MND Association. Team 14 are working on CopyClair, a rehabilitation app for the NHS, which will help people perform their physiotherapy exercises correctly and track their progress and improvements. Team 30 are working on an application for wheelchair users that will enable them to make use of exercise gaming and help users in a room distance scenario use their devices by using gesture or head tracking for navigation, or even issue voice commands using Ask Kita. Team 5 are working on a software reporting portal and Inair macros application of motion input. Some aspects of this project will be distributing a web portal form and database for users to give scores on the compatibility and comfort of using certain gestures on different software. It will also help in defining custom macros with the ALS-MND Association. Team 34 will be working on multi-touch, multi-users, Inair keyboard, and Inair digital inking. This will allow users to use an Inair keyboard using depth to register key presses that users can interact with using both hands. Finally, Team 35 will be working on a FIS kiosk for a care home setting that will allow users to order essentials, use a nighttime setting, interact with creativity apps, communicate with others, and access medical and emergency support.
The software is available. It's currently here on these URLs. And there's a project website with some example videos, which you can have a look at. There's also a research paper for citation if you wish to read more about the technical achievements made. I would very much like to ask all of your community to please try out the version 2.0 software, and please give my team of students suggestions and improvements on the form link that I've provided here. The design sessions are currently ongoing, and we hope to have some solutions ready for March, April 2022.
Oh, wow. Thank you so much to the students for taking on all these projects. This is huge. This is really amazing and really great work that they're doing. Let's see if there's questions. There's people, of course, saying thank you. And I see that the contact is being put in. It was in the chat. I think we'll put it in the question and answer too. I think that might be easier for people to connect to. One of the questions was about the different projects, which I think they answered very nicely, going through what the different teams were doing. And I love the idea that you are asking for everyone's feedback. And I think, again, just like I mentioned earlier, this is the group. These are, these are the people, the clinicians and the people living with ALS, MND and their caregivers who you're going to want to get this feedback from. So is there any questions coming in before I start? All right, so I know there was a group working with ALS, MND, and I love all the motion input and I love all that, but as people change, is that going to be built into the system so that it changes with them, or will they have to recalibrate it? How will that work along, say, for example, the journey?
Shall I go first, Sheena? In the previous discussion with Kathy and the team, it was described as an idea of an a la carte mode, where a user could choose mixing and matching different types of inputs, whether it's head gestures to show your ears, or if it's to use your nose to navigate, or if you actually want to move your hands, even the voice input and sound inputs that we're working on. The ability to swap in and change from the options will be in the next edition of this software. What I'm most interested in is, can some of your groups give us feedback and ideas and suggestions for the GUI, the user interface, of how that changing between the modules would like to look like? Because we know we can build the technical part of it, but to approach it in a way that is really satisfactory and easy to use with your user domain.
Yeah, I wonder if you'll need some, information when the person's logging in, for example, to say whether they're able to move.
Yes.
Like, will there be sort of a pre?
So my suggestion is that we have like a little workshop session to organize, and people we'll show some example drawings and sketches of what the students have come up with. And some of them looking at more of a survey questionnaire type thing, where it asks you certain questions and it leads you through the options that you want. But then for those who are very familiar with the system, but they just want to go in and set the things that they want. And so, what are the priorities and the ordering of things, and how do they expect the GUI to operate, in a really useful way for them? Yeah.
Mm-hmm. Mm-hmm.
I can add a tiny bit to that. Firstly, Sarah, thank you so much for having us join. It's an absolute privilege for us to be here today. I love the question about people, and part of our philosophy, especially within this project, has been people before technology. And that means having really brave conversations. My background is as an allied healthcare professional, as a registered dietitian and researcher. And so this for me feels like a long time coming, that we'll often be greeted with great technology that's been built up by engineers offsite, away from hospitals, away from clinical teams, away from people. Mm-hmm. And so for me, it's been part of the discipline for us as a team, and a really big team, to include people at every single step of the way. And so what we've shared with you are early versions of a new software. This isn't the end product, and we know that. And so we're having brave conversations to garner some of that feedback. Dean mentioned already the a la carte menu idea, which I love. I love it to bits because people are different, and it also suspends a sense of judgment as to what people need, and encourages us as a development team to ask about needs and wants, even if they change over time. There's nothing wrong with that. However, by building out things that are in their early stage, instead of describing something, which can sometimes become quite a technical conversation, by building it out and with the short demonstration that I shared with you, it's easier to experience what it is that we're trying to convey. And that often leads to a more meaningful conversation about what people may well want.
Absolutely. No, I your point that people before technology, that's, yes, that's you're speaking to a like-minded crowd here. Absolutely. And again, and also that whole point that, yes, the engineers, and we love engineers can build things and then they try it on each other, and the students all try it on each other, and they, not that they forget, but they don't know all the nuances to the end user. And so this is, yes, absolutely, putting the two together is fantastic. So there are some other questions coming in. So somebody did mention about distance and calibrating for that, but also asking about night or bright sunshine. How does that affect the?
So it was in the previous ALS MND meeting with Kathy that it was described what would happen in a night scenario, that someone, they need help, that there's a person staying with them all night and they want to get up, they want to go to the bathroom, they want water, they want things, and I spoke to a few GPs in our group to cover a few ideas on this, that you could have like wireless remotes and trigger events through a sound nudge or a small movement nudge, that just in low light is just a disturbance of movements in a certain direction, and that would be enough to trigger a sequence of events to happen. So we're specifically calling them Inair macros. That's the theme that the students are investigating, where the chain of events can be triggered by small but unique sets of motions. It could be like, you could make a triangle with your nose, and that's something, or if you can move your body in a certain way in a range, that would be enough to trigger a certain set of sequences. Exactly. We have done some initial tests with low light cameras, high aperture cameras, and infrared cameras. The results are very promising. The cheapest camera we found on Amazon was, I think, £14, and it was about 70% there for accuracy. So we were quite happy with that. And just raising the light just a little bit above near pitch blackness, it would actually get quite significant input. So we definitely want to test this with people and to have them see, what would the gestures look like. Bright sunlight, that hasn't been actually tested, and I think we do need to do some lighting tests for the absolute brightness, but that I don't see as a problem because we can use color filtering in software to reduce down the load on the process. More importantly is that things that would be monitoring all night long, we have begun this journey in a more sessional view of, you want to use some software and you start it up and use it. But in the view of this is the monitoring system running continuously throughout the night, there are some particular patterns that our engineering work is needed for our students to ensure resilience and robustness of that. And again, that will take some design decisions in collaboration with people who want to help with that. But I saw there's a question here from Dirk.
Before you move on to another question, may I just add to that first question that's just being answered, just looking at it from a slightly different lens? Is that okay if I add in? Amazing.
Yes.
It's a super question about lighting and proximity. My work sits over at Great Ormond Street Hospital, and so as part of my own research, in case it's helpful, I ensured that we did observations in advance to some of those areas and environments so that I could better understand some of the lighting and proximity needs. And so even prior to the first build cycles, we were having conversations about exactly that: space, lighting, obstructions, other types of trade-offs, because we know by including a new technology as part of quite a complex and risk-averse environment, and that's maybe talking to some of the clinicians joining today's call, it starts to get really complicated quite quickly. So it was great to have those conversations in advance, and that's published work. Now, once we'd built out early versions, for me, it was really important to re-engage again with similar clinicians and within the clinical simulation suite over at Great Ormond Street. And so we did that. And so Motion Input version 2 has been tested out in empty operating theatres. And that's only one example of quite a few different environments, but it is an area where space, proximity, and lighting are quite important. And what we found is that motion input, it works quite nicely up to about 1 meter away. And for some of the surgeons we started conversations with, that was really important. They needed a little bit of a distance from what would be the screen that they were interacting with. Secondly, we tried it at different levels of lighting that exist within the operating theatre. It worked well in the lower tube lights that were within the operating theatre, the lower level of lighting there. It's perhaps not as dark as some of the limited lighting could go, but that worked really well. It also worked under the focused light. And again, it maybe isn't quite the same as bright daylight, but under the bright focused light, kind of in and around what would be the operating bed, it worked really well within that environment too, even with a gloved hand. So we're starting to experiment, and it feels like we're only just beginning. As Dean mentioned, we've got loads and loads to try out, but it feels encouraging so far.
It sounds encouraging so far. Absolutely. And I love the idea of, you were talking about the a la carte menu, of having it so it could be set up as a motion detector. So proximity, you don't have to touch it, but if you move something, you can just use that as a call device. Like, and then later on, during that would be at night, and then during the day, you would use it as maybe a communication device or a way to access things. So I love that idea that you'd be able to do both things with it.
But one of the other recent experiments that we're looking at is field of view. So if you have a person quite far away from the table or quite close to the table, Sheena talked about the observations being 1 meter away. That's an optimal view for current webcams that have a specific degree of their field of view. Having particular lenses and glass in front of the webcam to optically magnify also worked in reactive ways. It does work. We don't need high resolution, we need the approximation. And so having little bits of glass filters in front actually do provide us with some information of relevance and usefulness. So if it is a larger room and it's a person sitting on their bed or a little bit further away, we think that there will be some valid data to fine tune this with. The 3D heat spaces model that we're working on is one of the masters teams is also there to record motions in a particular volumetric view. So within a cube space around the person, what their range of motions is. And that can be at a number of different distances. So these are all experiments that we are working towards to build up a portfolio of accuracy results that people can then choose from and make it possible to selectively approach it from the way that they want it. But I just want to mention Dirk's question is really important to us about the people who are over 60 years old. So a few of the participants that we trialed with, just family members, that they genuinely have difficulties with certain types of gestures. And even, for example, like trying to do a scrolling with 2 fingers, if they've got arthritis and they can't clench their fists, certain ranges of motions, none of those should be inhibiting factors in the system design. So we want to be able to enable you to set what you expect to be a scroll, to then relay that as an event to trigger, as opposed to we tell you how to scroll. And that's where we want to end the solution, where we can't do that well enough until we get people's feedback and to give us ideas and suggestions for what does it look like to record your way of scrolling a web page. Mm-hmm. How do you imagine your own motions and your own range of motions, how you want to scroll? Yeah.
Does licking your finger and going like that count?
That could work. That could easily work.
Absolutely.
That could easily work. Yeah.
All right, didn't really lick my fingers. All right, and then there's questions about I mean, I think we could go on and on about the future of all this, but working with the brain-computer interface technology, is that on the horizon?
No, not at this point in time. We are just working with technologies that are readily available or really cheap and easy to access.
It's a really important point, Dean, with what you say there. We say it all the time, Dean and I, and it's one of the things I love about working with UCL and especially with Dean is a shared working philosophy and ethic, that this is about using the tech that we've got. In the past, the reason we believe that some technologies that were touchless perhaps mainstreamed a little more slowly or didn't mainstream at all is because they required installation, assembly, it was expensive. And so learning from that, it was a wonderful moment where we decided that this would be about being inclusive in our approach, ensuring it wasn't about high cost and really complex assembly, about using the tech that we do have so we could reach the broadest audience that we could. And we keep going back to that. It, for me, feels really, really important.
Yes.
And I hope it stays as something central to the way in which we work.
Yeah, and that is such a key point, because when I see people in the clinic, they don't want to go out and buy something new. They want to use what they're using and show me how I can use what I'm using. And that sounds like it's exactly the way that you're looking at it.
The master's students are also building what's called the developer API, so that others can build third-party solutions to add in their own interactions into the system. So once we've built out the 3D gesture heat space, and we can leverage this ability to record shapes and motions and ranges of motions, it should be straightforward to add in additional technologies as people want to also add value to how it realigns to the actual day-to-day usage patterns of using a computer. So it's not that we would be building the BrainGate interface, but rather we'll publish a specification to enable those researching BrainGates to interface with our tech.
Exactly. That's
it. And I was just going to add to that again, another assumption, I guess, that Dean and I make, because we talk about this all the time, it's assumed, is that the work we're doing is open source. We firmly believe in the open source mandate. And we say that over and over again. This is about a paradigm shift with how people, whoever they might be, wherever they might be located, whatever their digital ability might be, how they in the future might interact with the future computer interfaces. And so to ensure that we include people from the get-go and at every juncture as we start building up, we've ensured that it's open source, it can be accessed, downloaded, recompiled, and as Dean had mentioned there, even with a kind of a developer function.
Well, we thank you so much for looking at it that way and for focusing on the people that are going to be using it. It's very encouraging for all of us as well. And it's, your enthusiasm is infectious. So we're excited. Now, be careful what you ask for. You ask all these people to give you feedback, and I'm pretty sure that you will. So if anyone out there living with ALS, MND want to be involved, they can also reach out to Kathy Cummings, and she can help funnel people to you as well.